this is Project 1, Iterative Processes in Chaos. I'm Chloe Evernham. This is my signature. This is today's date. It is May 10th, 2025. And as you can see on my computer, it is May 10th, 2025, 12:41 p.m. So basically, this is going to go over questions 19 through 21. Of which we are employing the recursive formula. So basically, first question, this is the formula we're going to be employing because we're given an R value and an X of 0. So we're calculating our first 49 sequence values, and when we apply that to our formula here, we can see that 3.2 times X of 0 times 1 minus X of 0, and we do that for every single value. Now, since we're employing statistics here, it is easiest to plug this in to a table. Where did I go? Here I am. We plug this into our table here. So as we can see, we get some repeating values that are similar. They're not exactly the same, but they are similar. We go all the way down to 49. This is question 19 here. So we're going to go back over here. And upon plugging into our GeoGebra and our Math Insights, we see there's no convergence. No convergence. Oop, where'd we go? Sorry. No convergence, and it is jumping back and forth between similar values. So we have a 2-period cycle. These are just some examples of repeating values. They're very similar. And we plug in our g of x, which is as reinstated before, 3.2 times x of 0 times 1 minus x of 0, so on and so forth until 49. When we plug it into this applet, we do the same formula, and we have just a bigger view of the back and forth periods. Very consistent, very uniform. Question 20. Now we're going to employ R of 3.5 and X of 0. We're keeping it 0.2. So we plug that in here, 3.5 times X of 0 times 1 minus X of 0. We go back to our stats here. And as you can see, same story. We have very similar values kind of back and forth. Where did I go? There I am. So we have no convergence here. As you can see, we've got this crazy structure formed when we go all the way down to 49th value, as we did before. And given the pattern that we find in our numerical, as you can see, it's a 1, 2, 3, 4 jumping back and forth pattern, or can be an 8-period pattern. So that gives us a period of either 4 or 8, and we still have those repeating values. And even larger on the scale, we can see it's the back and forth, except here there is more of a length, and it is less, it's less quick to bounce. Okay, so for 21, now we're going all the way up to R equals 4. X of 0, we're still keeping that the same. So we go to our formula, same story here. We're literally just plugging in numbers to the recursive formula. So X of 1 equals 4 times X of 0 times 1 minus X of 0, so on and so forth. Plug in our numbers here. I want to also note that I have a formula I'm using here. It is the same formula that you can see here. As you can see, I'm doing the formula every time. Now here, look at this crazy thing. There is zero rhyme and reason to this. There's no convergence. As you can see, I went all the way down to the 49th value here. It is extremely chaotic. No period, because all of the numbers that we get when we plug in our formula, they're just all over the place. There's no rhyme or reason to this. So no repetition or stabilization, and that is further proof here when we look. there is zero trends. Well, I shouldn't say that. There are some repeated trends, but it is chaotic and it is hard to follow and, yeah, not consistent enough to have a period. So that was questions 19 through 21 of Project 1.